Okay, section 7.5 is on using elimination to solve a system of linear equations, and the elimination method is also an algebraic method that can be used to solve a system of linear equations, and in my opinion is probably the easiest one to use, because with substitution method, although we didn't get into too many complicated ones in the last section, a lot of times in substitution method there are equations when you're given a system that it isn't easy to rewrite one equation in terms of the other variable without getting a lot of fractions involved and kind of sometimes ending up with a really complicated equation that you have to solve. And if you're not comfortable working with fractions, it can be kind of messy. So elimination method kind of avoids that if fractions are involved until the end. So we can do an example here now to show you how to use the elimination method. So the first example has 3x minus 4y equals negative 23 and 2x plus 5y 2y plus 5x minus 5 equals 0 as your given equations. So the first thing you have to do if you're doing the elimination method is to line up your equations with the same variables underneath each other. So for example, the first equation has x's and then y's equals constants. So both equations should be written in that form. So first equation is okay. You've got x's and then y's equal your constant. So then you have to line up the other equations so that everything is in the same order as the first equation. So 2y plus 5x, we can turn those around and write it as 5x plus 2y. We don't have to change the sign in front because you're still on the left side of the equal sign. However, that negative 5, we want to move that over to the other side of the equal sign. So we're going to add 5 to both sides, so it becomes a positive 5 on the other side of the equal sign. So now both of my equations are x's underneath each other, y's underneath each other, equals underneath each other, constants underneath each other, so they look the same. So the next step is to decide which variable you want to eliminate. And you look at both variables and what's in front, the coefficient in front of both variables, and see how could I get, what you want is the opposites in front of those variables. So you want the opposite coefficient. If one is positive 4, you want the other one to be negative 4. If one is 6, you want the other one to be negative 6, that sort of thing. But you have to pick one of the variables to do that. And if I look at the two equations I have from the last step, I think it's easiest to get rid of the y, because all I need to do is multiply the bottom equation, equation 2, by 2, and then I'd have a positive 4 in front of the y, which is the opposite of what's in front of the y in equation 1. So that's what I'm going to do. I'm going to keep the first equation the same, 3x minus 4y equals negative 23. I'm not going to make any change to that one. And I'm going to multiply the second equation by 2. So that's going to give me 2 times 5x is going to be 10x, 2 times 4y is going to be positive 4y, and 2 times 5 is going to be 10. And by multiplying everything on both sides of the equation, I have not changed any solutions to the equation, but I have changed the look of the equation, and it's an equivalent equation. So the next step would be to add those two lines together. So basically add your x terms, 3x and 10x is going to be 13x. And then if you add the y terms, they're going to cancel each other out. So there's no y's left. And then if you add the constants, you're going to get negative 13, negative 23 and 10. So the next step is to take that equation that we have now and to solve for the variable that remains, which in this case is x. So if we have 13x equals negative 13 and we want to get the x by itself, we're going to have to divide both sides by 13, and that gives us x equals negative 1. So now we have x equals negative 1, so we know the value of x, but we need to find y. So what we need to do now is go back into one of the given equations that we started with and substitute negative 1 in for x in your equation, and then solve the resulting equation for y. So I'm just going to pick the first equation to sub back into. So it was 3x. First equation was 3x minus 4y equal negative 23, and it doesn't matter which equation you pick. to sub that -1 back into, whichever one looks easier to if you want. You're going to get the same answer either way. So x is -1, so just replace the x with -1. I meant to put minus there, not equals. So minus 4y equals -23. And then that's -3 minus 4y equals -23. So -4y equals -23 plus 3. And -4y equals -20. And then I divide both sides by -4 to get the y by itself. And that's going to give me, just come over here, y equals 5. So now I know what x is and I know what y is. And if we can still do the same thing we do with the substitution method, we can go back and plug -1 in for x and 5 in for y in our original equations. So 3, if we go back to the original, 3 times the -1 is -3. Minus 4 times 5 is -20. So -3 minus 20 is -23, so it works in the first equation. And we said y was 5, so 2 times y, 2 times 5 would be 10, plus 5 times x was -1, so 5 times the -1 would be -5. So 10 minus 5, which would be 5, minus another 5 would be 0. So our a solution of x is -1 and y is 5 works in both equations, so therefore it is a solution to the system. Okay, example 2 is another system that tries to solve using the elimination method. And this one here is already set up in the way that we want it. We already have the x's underneath each other, the y's underneath each other, equals underneath each other, and the numbers underneath each other. So they're both written in the same order. But if you look carefully, this one here, it's a little bit easier than the last one because the x's, the y's, already have the opposite coefficients of 3 and -3 that we want. So we don't have to do any multiplying to get opposite coefficients. We can go right ahead to the addition step. And sometimes the elimination method is actually called the multiplication addition method because you do have to multiply first, usually, and then add the two lines. So we're just going to skip the multiplication step now and go right to the addition step. And if we add these two, we get 5x's. 2x and 3x is 5x. Positive 3y, negative 3y is going to cancel out your y's, no y's left. And you get equal to 15. And then if you want to divide by 5 to get your x value, you'll get x is equal to 3. Just erase that there, marker made. And then you want to solve to figure out what y is, so you go back into one of your original equations, and I'm going to take the first one. 2x plus 3y was 5, and we know now that x is 3. And that's going to give you 6 plus 3y is 5. So then 3y is 5 minus 6. So then 3y is -1. And then if you divide both sides by 3, you get that. Y equals -1/3. And if you go back and check to see if your solution is right, 2 times x is 2 times 3 is 6. So 6 and 3 times -1/3 is going to be -1. So 6 minus 1 is 5. It works in the first equation. And then if you plug it back in to the second equation, 3 times 3, because x is 3, so 3 times 3 is 9, minus 3 times a -1/3 is going to be plus 1. So that would be 9 plus 1 is 10. So your equation system, a solution of x is 3 and y is -1/3 is the correct solution. Alright, so the next example neither the the equations are written in the right order with the x's underneath each other, y's underneath each other, and the constants off on the other side of the equation sign, equal sign by themselves. so that they both are written the same way, so we've got that step completed for us. The next step is to figure out which variable we're going to eliminate, either x or y. And neither one of these ones here is as obvious as the last two examples, but I'm going to just choose to eliminate x. And if I'm going to eliminate x, and it doesn't really matter again which one you eliminate, but I just picked x, I would want to get something that the opposite coefficients in front of both x's. So if I look at the numbers that are there, 2 and 3, I know that 6 is a multiple of 2 and 3. So I'm going to try to get 6 in front of both those x's, but I want one of them to be negative. So I'm going to multiply the top equation by a negative 3, and then that's going to give me negative 6x minus a 9y equals negative 18, because I got to multiply everything on both sides of the equation by negative 3. Then if I take the bottom equation and multiply it by 2, I will get 2 times 3 is positive 6x and positive 8y and positive 14. So now I've got opposite coefficients in front of x. So when I add the two lines, the x's are going to cancel, and I'm left with negative 9y and 8y is negative y equals negative 18 and 14 is negative 4. So then if I solve for y, divide both sides by negative 1, I'm going to get y equals positive 4. And now I'm going to substitute y equals 4 into equation 1 or 2 to get x. So I'm going to pick equation 1, so 2x plus 3 times y, just figured out y was 4, so I'm going to plug 4 in for y, equals 6. I'm plugging into the first equation here. So that gives you 2x plus 12 equals 6. So that means 2x equals 6. Take away 12, which means 2x is negative 6. And then if you divide both sides by 2 to get x by itself, you get x equals negative 3. So we have a solution of x is negative 3 and y is 4. If we go back and check, 2 times negative 3 is negative 6, plus 3 times 4 is 12, so negative 6 plus 12 is 6, so it works in the first equation. And then we check it in the second equation. 3 times a negative 3 is negative 9, plus 4 times 4 is 16, so negative 9 plus 16 is 7, so it works in the second equation. So our solution is correct. Okay, so the first example here, they're not lined up properly. So we have to first do that. So I'm going to put x's first, then the y. So the negative 3y would come back over to the left-hand side of the equation. So that would become plus 3y equals 8 doesn't move, so it stays positive. And the bottom one is in that order of x's first, then y's equals constant. So now the two equations are lined up, both the same way. And in this one, when I look at which variable is easiest to eliminate, I think x would be easiest to eliminate, because all I would need to do is take my equation 1 and multiply it by positive 2, and that would give me a negative 4 in front of the x, and I have a positive 4 in front of the x of the second equation, so they would be opposites. So I'm going to take equation 1, and multiply it by 2. It doesn't look like a 2, so I'm just going to fix that. So that would give me negative 4x plus 6y equals 16. And then the bottom equation stays the same. Equation 2 stays the same. So now that I have opposite coefficients in front of the x, when I add those two lines, the x's are going to cancel. That leaves me with 1y equals 16 minus 14 is 2. So there's y already for us. And to get x, we go back to either one of the equations. I'm going to go back to the second one. Actually, I'm going to go back to the first one because I will have the x term isolated already. So negative 2x equals negative 3 times y, we just figured out was 2, plus 8. So that was going to be negative 2x equals negative 6 plus 8, which is going to give you negative 2x is 2. And then you want to divide out your coefficient of your x term. And that's going to give you x is negative 1. And a quick check. We go back to the original equations. Negative 2 times negative 1 is positive 2. And then the other side would be negative 3 times 2 is negative 6 plus 8, which is 2. So the first equation is true when you plug in negative 1 for x and 2 for y. And the second equation, 4 times 2 is 8. 4 times negative 1. 4 times negative 1 is negative 4. Minus 5 times 2 is negative 10. So negative 4 minus 10 is negative 14. So it works in the second equation. So we know we have the correct solution. X is negative 1 and y is 2 because it works in both equations. So the next example, again, the equations aren't lined up properly. So we're going to do that first. So if the first one is x's then y's equals constants, then we just have to rearrange the bottom equation. You're not changing to the other side of the equal sign, so the positive 3x stays 3x, and the positive 2y stays positive 2y. Just putting them in different order. And then if I want to eliminate a variable here, neither one of them is obvious to eliminate the x or the y. There's not like a single multiplication that can be done to get opposite coefficients, so we're going to have to multiply both equations by something. So where the y's already have one positive and one negative, I'm going to pick the y's. But again, you can pick the x's if you want, but just make sure that one of them has a negative in front of it. I'm going to pick the y's. So if you look at the numbers in front of the y's, negative 5 and 2, 10 is a common multiple of 5 and 2. So that's what I'm going to try to get one to be a positive 10 and one to be a negative 10. So that means I'm going to need to multiply the top equation by 2 to get a negative 10 in front of the y. So that will give me 4x minus 10y equals 52. And then the bottom equation, I would want a positive 10y, so I'm going to multiply that by 5, everything by 5 in the second equation. That's going to give me 15x plus 10y equals 5. So I'm going to add those two lines together now, and I'm going to get 4x and 15x is 19x. Negative 10y and positive 10y are going to cancel each other out, so there's no y's. We've eliminated the y's. And 52 and 5 is 57. So then I want to isolate x by dividing both sides of the equation by the number in front of x, which is 19. And then x is 57 divided by 19, which is 3. Then I can go back and sub x equals 3 into one of the given equations. To find the variable we don't have, which is y. So I'll just pick the first one. So 2 times x is 2 times 3 now, minus 5y is 26. So it's going to be 6 minus 5y is 26. And then I isolate the y term, so 26 minus 6. So get the y term by itself. Now I've got 20, and then I'm going to divide both sides by what's in front of y, which is a negative 5. So y equals negative 4. So x is 3 and y is negative 4, and if we go back and check into our equations that were given, 2 times 3 is 6, minus 5 times the negative 4 is plus 20, so 6 plus 20 is 26, so it works in the first equation. And second equation, 2 times negative 4 is negative 8. Negative 8 plus 3 times 3 is 9. Negative 8 plus 9 is 1. So it works in the second equation. So we know our solution of x equals 3 and y equals negative 4 is correct. Our next system, we call this equation 1, this equation 2, they're already lined up in the proper order. Both of them are in the same order. X's, y's equal constants. And again, there's not really one variable that's easier to eliminate than the others, so both of them would involve getting rid of the x's, or the y's would involve multiplying both equations by something. I'm going to get rid of the y's just because there's a negative already in front of one y and a positive in front of the other. And if you look at the numbers 4 and 3, 12 is a common multiple of 4 and 3, so that would mean I would need to multiply the top equation by 3 to get a negative 12 in front of y, and the bottom equation by 4 to get a positive 12 in front of the y. So 3 times equation 1 would be 9x minus 12y equals 39. And the bottom equation would need 4 times equation 2, which would be 20x plus 12y, and 4 times 12 is 48. And we already have one positive and one negative. If you had chosen to get rid of the x's, you would have to remember to multiply one of those equations by negative so that you'd have opposite coefficients. Alright, so then if we add the two lines, we've got 29x. We've got no y's because they would cancel each other out. And then 39 plus 48 is 87. And then if you divide both sides by 29 to get the x by itself, you've got x is 3. And then you go back and sub x equals 3 into one of the given equations, 1 or 2, to get y. So I'm just going to again pick the first one, 3x minus 4y equals 13. So that means 3 times 3 minus 4y equals 13. So 9 minus 4y is 13. And then isolate your y. So 13 minus 9, which is going to be 4, and then divide both sides by negative 4. So you've got an x value of 3 and a y value of negative 1. And I want to just quickly check. 3 times 3 is 9. Minus 4 times negative 1 is going to be plus 4. 9 plus 4 is 13, so it works in the first equation. And then check in the second equation. 5 times 3 is 15. 15 plus 3 times negative 1 is negative 3. 15 take away 3 is 12, so it works in the second equation. So the next example on this page involves solving a linear system with fractional coefficients. And we start this one off the same way we did the ones with fractional coefficients in substitution method. We eliminate the fractions first to start working with whole numbers. Just makes it a little bit easier. So if you remember what we did first, we looked at the denominators of the fractions involved in each equation. So the first equation has 5, 4, and 2 as denominators. So the first thing to do is to multiply by constants that will eliminate the denominators. So a common multiple of 5, 4, and 2 we said would be 20. So we're going to eliminate the fractions first. Okay, so come by multiplying each by the common denominator. fractions in that equation. So the first one would be, we'd need 20 would be the common denominator, so you multiply that by equation 1, and that will give you 20 times 2/5 x plus 20 times 3/4 y equals 20 times 5/2. And that's going to give you 20, now keep in mind that's understood to be 20/1. So when you multiply fractions, you multiply tops and you multiply bottoms. So you're going to get 40/5, which is 8x. Next one is going to give you 60/4, which is going to give you 15. 60/4 is 15. Y. And the last one is going to be 100/2, which is 50. Or you can cancel if you want. 2 goes in 20. 10 times 5 is 50. So that would be our new first equation. And then we're going to look at the common denominator for the second equation would be 6. So we're going to multiply the second equation by 6. So it's going to be 6 times -2/3 x plus 6 times a 6th y. Because if you're multiplying the left side of the equation, you have to use distributive property and multiply the 6 by both parts, right? And then the next one, so it'll be 6 times -7. So if you work those out, that's understood again to be 6/1. So that would be -12/3, which is going to be -4x. And the next would be 6/6, which is 1y, equals -42. And so now we're going to solve the resulting system. Which would be 8x plus 15y equals 50, and -4x plus y equals -42. So if we're using, and I'm going to call this my new equation 1 and this my new equation 2. So if we're going to use elimination, probably the easiest thing to do here would be to multiply the second equation by 2, so then you'd have an 8x in the first equation and a -8x in the second equation. So the first equation is going to stay the same. And we're going to multiply the second equation by 2. And that's going to give you -8x plus 2y equals -84. When we add those two lines, 8x and the -8x are going to cancel each other out. We're left with 17y equals 50, and -84 is -34. So that's going to give you 17y equals -34, and then you divide both sides by 17 to get y. Y would equal -2. And then you can go back. Usually it tells you to go back to the original equation, but the original equation is kind of messy, so we're going to go back to our nicer equation 1, or equation 2, and I'm going to pick equation 2 just because the numbers are a little smaller. So equation 2 would be -4x plus y equals -42, and then we've got -4x y we just worked out to be -2. So then -4x equals -42. Bring that 2 over, is going to become -2. Brought to the other side is going to become +2, or add 2 to both sides, whatever way you want to look at it. So -4x equals -40, and then divide both sides by -4 to get x by itself. I got an extra little mark in there that shouldn't be there. So then x is 10. And you can go back and actually plug those values into the original equations to make sure they work. So if we check 10, 2/5 of 10 is 20 over 5, which is 4. And 3/4 of -2 would be -6 over 4, which reduces to -3 over 2. So 4, if you put that over a common denominator of 2, would be 8 over 2, minus 3 over 2 is 5 over 2, so it does work in the first equation. And then if you check it in the second equation, -2/3 of 10 would be -20 over 3, plus 1/6 of -2, which would be -2 over 6 or -1/3. So you've got -20 over 3 minus 1 over 3 is -21 over 3, which is -7. So it does work in both equations. So here's another example with fractional coefficients. So I'm going to take the first equation, and to get rid of those fractional coefficients, the common denominator of 3, 2, and 2 would be 6. So I'm going to multiply everything by 6. And in the bottom one, I'm going to multiply everything by the common denominator of 4. So the first one is 6 times 2/3 x minus 6 times 1/2 y equals 6 times 13 over 2. And if you work that out, keep in mind that's over 1, over 1, over 1. So that'd be 12 over 3, which is 4x, minus 6 over 2, which is going to be -3y. And this one here, rather than multiply 6 by 13, I'm going to go 2 goes into 6 3 times. So that's 3 times 13 is 39. So this is going to be my new equation 1. And then this equation, we multiply everything by 4, so that's 4 times 1/2 x plus 4 times 1/4 y equals 4 times 7 over 4. And again, 4 is understood to be 4 over 1. So that's going to be 4 times 1/2 is 4 over 2, which is 2x, plus 4's cancel, that's going to leave you with just y, and the 4's cancel there, which is going to leave you with 7. So there's my equation 2. So I'm going to be solving 4x minus 3y equals 39, and 2x plus y equals 7. I'm going to eliminate my y's, because all I have to do to eliminate y is multiply the bottom equation by 3. So the first equation stays the same. And the second equation is going to be 3 times the second equation, which is going to be 6x plus 3y. Now I have opposite coefficients in front of my y. And don't forget to multiply 3 by the 7, which is going to give you 21. So when you add those two, 4x and 6x is going to give you 10x. -3y and +3y give you no y's. And then that's going to give you 60. 39 and 21. And then if you divide out the 10 that's in front of the x, you will get x is 6. So then I'm going to take my x value 6 and go back to equation 1 or 2. And I'm going to plug it into the second equation because that has nothing in front of y. So 2 times, this is equation 2, 2 times x was 6 plus the y equals 7. So 12 plus y is 7. So y would equal 7 take away 12, or -5. So if we just go back and check, I don't have a whole lot of room there to write the workings, we'll just have to try our best by doing it in our head. So if we take x is 6, 2/3, go back to the original equations, 2/3 of 6 would be 2 over 3 times 6 over 1, or 12 over 3, which is 4, minus 1/2 times 5, -5, is going to be +5 over 2. So we said that was 4 plus 5 over 2, and 4, if you write that over a common denominator, would be 8 over 2 plus 5 over 2 is 13 over 2, so it works in the first equation. And then if you check it in the second equation, a half of 6 is 3, and a quarter of negative 5 is negative 5 over 4. So 3 minus 5 over 4, if you put 3 over a common denominator of 4, that would be 12 over 4, minus 5 over 4 will equal 7 over 4, so it works in both equations. If you find it hard to do it in your head, just do it to check on paper, but I don't have a whole lot of space here to write those for you. Okay, so the next equation, I'm going to multiply the top equation by 10 to get rid of the fractions, and the bottom one by 8. So that's going to give me 10 times a half is going to be 5x, minus 10 times 4 over 5 is going to be minus 40 over 5, which is minus 8y, and 10 times negative 2 is negative 20. So kind of skipped a step there, just kind of did them each in my head there, did 10 times each of those things. And then this one here, 8 times y equals 8 times a quarter is going to be 8 over 4, or 2x, and then 8 times a negative 3 over 8 is going to be negative 24 over 8, which is negative 3. So these are your two equations, but they're not written in the same order, so we're going to do that first. So 5x minus 8y equals negative 20, and then if we put the second one in the same order, we're going to have to bring that 2x over the other side, so it becomes a negative 2x, positive 8y, and equals negative 3. And this one works out nice because the opposites, the coefficients of y are already opposites, so we can just go ahead and skip another multiplication step. All we have to do is just add them. So 5x minus 2x is going to be 3x, no y's, equal negative 23, and then we got to divide both sides by 3, so that's going to give you x is negative 23 over 3, and then if we go back to find the y, I'm going to use the second equation. I'm going to use this one right here. 8y equals 2 times negative 23 over 3 minus 3 is negative 46 over 3 minus 3. So just going to put these over common denominator first, which that's understood to be over 1, so if you put that over 3, it's going to be negative 9 over 3, multiply top by bottom by 3, top by 3, and that's going to give you negative 55 over 3. And then dividing both sides by 8 is the same as multiplying both sides by the reciprocal, 1 over 8. I'm just going to use that method for this one because we got fractions. And that gives you y equals negative 55 over 24. Now, those answers aren't real nice numbers, so to go back and plug those in my head and work it out from the given equation would be kind of difficult. So I'm just going to use the calculator. I had some scrap paper there. I could try to show the workings on scrap paper, but I'm going to put in the calculator 1/2 is 1 divided by 2, or 0.5. So 0.5 times negative 23 over 3, so negative 23 divided by 3. And then I'm going to subtract from that, minus, and I'm going to use brackets, 4/5, so 4 divided by 5 is 0.8, or you can just go 4 divided by 5 if you want in your calculator. Then you got to multiply that by brackets, negative 55 divided by 24, and you should get negative 2 is the answer, so it works in the first equation. And then the second equation, we'll just see what 1/4 x minus 3/8 is supposed to give us what y is. So 1/4 would be 0.25 times x is negative 23 over 3, so negative 23 divided by 3 in brackets. And then I'm going to say subtract in brackets 3 divided by 8. Close my brackets. And I get negative 2.2916667 comes up in the calculator. And if I check negative 55 divided by 24, that's the same decimal as what negative 55 over 24 is. So that is what y is. So it works in the second equation. So we know we've got it correct. Alright, so word problems involving linear systems. So the first example there says create a linear system to model the situation. So you would have to read your question first and see what things, two things usually they'd be looking for. So this is a cable company charges $85 for a customer who rents 3 digital boxes and chooses 5 theme packs. Another customer pays $54 when they rent 2 digital boxes and choose 3 theme packs. So assuming that the digital boxes and the theme packs are exactly the same for both, like same price in both situations, we would have as our variables, we could let, those are 2 things we're looking for, so we will let D equal the cost of digital boxes and T equal the cost of theme packs. So our first equation could be that 3D, 3 digital packs plus 5 theme packs cost $85. And the other equation would be that 2 digital boxes plus 3 theme packs cost $54. Okay, so question B says now that assuming that the theme packs and digital boxes cost the same for each customer, that's what we assumed in our system up there, what's the individual charge for a digital box and a theme pack? So we're going to solve that system. And if I call this equation 1 and this equation 2, I'm going to eliminate my D's. So I'm going to multiply the top equation by 2. And that's going to give me 6D plus 10T equals 170. In the bottom equation I would need to have a negative 6 in front of the D, so I'm going to need a negative 3 times the second equation, which will give me negative 6D minus 9T equals negative 162. 3 times, negative 3 times 54 would be negative 162. So all I did there was multiply negative 3 by the 2 and got negative 16, negative 3 by the term 3t and got negative 19, negative 3 by the 54 to get negative 162. So now I'm going to add the 2 lines. My 6t and negative 6t are going to give me no d's. 10t and negative 9t is going to give me 1t. And 170 and negative 162 is going to give me 8. So it looks like theme packs are $8 each. And then to get my cost of the digital boxes, I'm going to go back to one of my original equations, and I'll just pick the second one there. 2D plus 3t, we know is 54 from our second equation, so we just found out that the t was 8. So therefore 2d plus 24 has to equal 54. So therefore 2d has to equal 54. Take away 24. 2d is 30. And then if I divide both sides by 2, I get that the digital box is 15. And you can go back and check to see if that's correct by plugging it into your original system. So 3 times D, if we go back up to part A, 3 times D is 45. 3 times 15 is 45 plus 5 times T we said was 8, so 45 plus 40 does give you 85. And then if you look at the second equation, 2 times the digital, so 2 times 15 is 30, plus 3 times t was 8, so 3 times 8 is 24, 30 plus 24 is 54. So we know our solution to our system is correct. Okay, so the next example is an investment one again. So you're given you invested $2,000, part at an annual interest rate of 8% and the rest at an annual interest rate of 10%. After 1 year, the total interest was 119. How much money did Nuri invest at each rate? So the two things we're looking for is the amount at each rate, basically how much you invested at each rate. So we let A be the amount invested at 8% and B equal amount invested at 10%. Then one equation would be A plus B, total amount invested was 2,000. And the other equation would be that decimal 08, so 8% of A would be the interest, 8% of A, and 10%, so decimal 10% of B should give you total interest of 190. So those would be our two equations, equation 1 and equation 2. So if I take equation 1 and multiply it by negative decimal 0.8, or negative decimal 10 if I want to get rid of the b's, I would be able to eliminate one of my variables. So I'm going to eliminate A. So I'm going to multiply the first equation by negative 0.08 by equation 1, which is going to give me negative 0.08 A minus negative 0.08 B equals 2,000 times decimal 0.8. Negative decimal is negative 160. And then the second equation, just leave the same. Whoops. Should be 0.10 there, sorry. B equals 190. So when I add those two lines together, I'm going to get 0, because these two are going to cancel, 0.02 B equals 30. So that's going to give me 0.02 B equals 30. So if I divide both sides, so I'll get B equals 1,500. And then if I go back, the easiest equation to work with now is the first one. So we have A plus B is 2,000. So if we sub B equals 1,500 into equation 1, we get A plus 1,500 is 2,000, which means that A would be 2,000, take off 1,500, which means A would be 500. And both of those solutions for A and B, A 500, B 1,500, will add to give you 2,000 in equation 1, and 8% of 500 plus 10% of 1,500 does add up to give you $190. So that solution is correct because it works in both equations. Okay, question number 2. Maria has a container filled with dimes and nickels. When she organizes and counts the money in her container, she discovers that there are 10 more nickels than half the number of dimes, and she has a total of $19.75. So you have to create a linear system to model this and then solve it to determine how many of each coin she has. So in the question there, we know the two things we're looking for are the number of each coin she has. So we're going to start off with assigning variables to those two things. So let n be the number of nickels in the container. And we're going to let d be the number of dimes. In that container. So the first equation, and we need to come up with two equations now with those two unknowns. So the first equation, it says that she discovers there are 10 more nickels than half the number of dimes. So that means one equation can be nickels, the number of nickels is half the number of dimes, so 0.5 times the number of dimes, plus 10. And the other equation has to do with the value of the coins, which is 1975. And we know that means that decimal 0.5, because that's the dollar value of a nickel. So decimal 0.5 times the number of nickels plus 0.10, which is the dollar value of dimes, times the number of dimes, should equal 1975. Now, if I were given this word problem and it wasn't in a section about solving systems of linear equations using the method of elimination, I would probably solve this system using substitution, because it's nicely set up with the n variable. The first equation has the n variable by itself, and you can use that as your star equation. But we will solve this one by elimination, since this is the section that we're doing right now. So the first thing we need to do is put both equations in the same order. So if I kind of follow the order of the second equation there, that would mean the first equation would be rewritten as n minus 0.5d equals 10. So you get your n's first, then your d's, then your constants on the other side. So the second equation is already written in that form. So 0.05n plus 0.10d equals 1975. So there's equation 1 and equation 2. So now we have to eliminate one of our variables, and probably the easiest one to eliminate is your n, because all I'd need to do is multiply the top equation by, the first equation by negative 0.05, and then I would have opposite coefficients in front of both variables, both n variables. So this would give us negative 0.05n, and then a negative times a negative is going to be positive 0.025d equals 10 times a negative 0.05 is going to be decimal 50, but it's going to be negative because it's multiplied by a negative there. So then we have the second equation is not going to change. And then now that we have opposite coefficients in front of the n, we can go ahead and add the two lines. So the negative 0.05n and the positive 0.05n are going to cancel each other out. And then I'm going to be left with 0.125d equal negative decimal 50 plus 1975 is basically the same as saying 1975 take off 50 cents, which is 1925. And then I want to get the d by itself, so I'm going to divide both sides by 0.125. And that's going to give me $154 for the value of d. So there's 154 dimes, and then you want to go back to one of your given equations, and the easiest one to go back to get nickels is that very first equation we wrote down, n equal 0.5 d plus 10. So we're going to sub D equal 154 into this equation here to get the n value. And that would be n equals 0.5 times 154 plus 10. So that's going to be 77 plus 10. So n would equal 87. And D was 154. And you can just go back and check to make sure that those two values work in your equations that you have. The number of nickels is half the number of dimes, and half the number of dimes is 77 plus 10, so that is correct. And then if you check 5 cents for every nickel, so 87 times 5 cents plus 10 cents for every dime, so 10 cents times each of the 154 dimes does give you a total of 1975. So therefore, the number of nickels in the container was 87, and the number of dimes was 154. So the container has 87 nickels and 154 dimes. Okay. And there's some questions there now. We're finished section 7.5. So there's some questions on page 437 to 439 of your textbook that you can try to practice this.